All right, welcome back to the SciMax channel. Today I'm going to explore using gptel for a different task than I've used before. This is a recent paper of mine that has been accepted, and we can go to this URL, we can get a PDF. If we look at it here, then this is about uncertainty quantification and graph neural networks with shallow ensembles. And there's some authors. We can look and kind of scroll through here. What I'm going to do is ask gptel to extract some information, maybe do some summaries, and I want to get down to a particular table that we'll try to extract some data from. There's some figures we might also ask about. We'll see. Here's a table, table 1. And then this is the table I want to extract from there. All right. So typically what I end up doing is I have an org file here. We'll go ahead and turn on gptel mode first. And I've changed something down here. So we're going to try the Gemini Flash. If I click on this, you get to the menu where you can change the model. You can turn tools on or off. And all of these other options. There's a lot there. Let's start by summarize the title and authors of this paper. And then I'm just going to send this and see what Gemini does. One way I think about doing this kind of sequential things is you're building up context for the future, and here we are able to get the uncertainty quantification title and the authors pretty reasonably. How about summarize in a concise paragraph what this paper is about. And if you've been following these, I changed the way the outputs are fontified, so I got rid of the blue background. I felt it was a little bit intrusive. Now we just have a light or a dark blue-ish that is distinct from black, and that way I can visually see what's what. And this is persistent. These things get stored up in this properties, so we have all of this information here. And when we reopen this buffer later, it will be refontified. All right, so it's going to summarize, focus. This Gemini says a lot about what it's doing. And then it tells me it's exploring using depots with GNNs on the Schnepp model. That's correct to quantify uncertainty. We demonstrate effectiveness in looking at in-domain and out-of-domain across a couple of data sets. And it does successfully identify some things. It does have some limitations, especially in discerning subtle structural differences within the same elemental composition. That's also correct. That was true in the gold data set. And that's a short, brief summary. It's probably not much better than what is in the abstract. But now I have it here, and I didn't have to copy and paste it exactly. We got a different summary of it. All right, let's see if we can extract table 2 into an org table. Summarize the lowest and highest entries. I can see this being really useful for trying to get data into a form that you might reuse. Say you were going to make a bar plot of your own. So we have this, and then we have the lowest variance and the highest variance, and we might study these things like so. It's maybe worth comparing some of these. We have 9, 9, 7, 8, 8, 8, 7, 8, 11, 16, 22, 62, 82. Those all look more or less correct. So that seems pretty reasonable. And then if I wanted to use this, I would have to put a name here. Let's say variance data. And then I could, down here, let's ask Gemini to do this. Make a Python script to plot the variance of, let's say, the alcohols as a bar plot. Now, I don't know what it's going to do here. In org mode, I would use that as a data source. Let's see if we can do that. Use the variance data table as a data source in the org source block. And let me just tell it to do it in Jupyter Python. All right, let's see what that does. You can see down here we're waiting. Another thing that I changed is since last time I found that my Jupyter header line conflicted with the one from gptel, I'm getting rid of that here and using this mode line down here. It's a little less clear that what's happening, but it does sort of the same thing. All right, this looks like it did exactly what I hoped it would do. It uses a var heading with variance data, although here it's variance data, so I need to fix that. It's close, but it's not quite right. Maybe the var is variance data table. It did do the right thing here, but I think we don't need a colon there. So I'll just get rid of that. That's my experience with org mode. This is kind of interesting. I guess I didn't think it would do all of this because, and we don't actually need these. I wouldn't write this, so I'm going to delete it. Let's see if this runs. I guess that this is not going to run quite right. And there's a lot of extra stuff here. I'm going to delete. I don't need to know those. I never use plot.show. And let's just get rid of these. And I guess this is going to give me an error because there's some weird stuff here. All right, so this has gotten confused, and what it doesn't know is that this is going to get passed in as a table, not as a string. So I think we can eliminate this and just from here say that data equals variance data table. That's probably going to fix this. Then read the table. This is probably not necessary. Let's try to rewrite this section. Make a data frame from data. Let's see what happens there. So we're waiting. You can see waiting down here. I'm still waiting. Must be thinking how to do that. One thing that would be nice is if there was a way to stop this. Like, I don't know what it's waiting on, but I sort of know what to do next. But now I have to wait for it to finish. Okay, so let's go ahead and do this. I'm going to split this and just print data to make sure I know what it looks like. We have just the actual data here. There's no column names. I think that's because there is some way I need to include that up here. While that's going, let me show you how we can use another buffer. So if I go to gptel buffer B here and select this, I don't know why it's making me do that. Then here I can say in org mode, I have a table with column names. How do I include them as a variable in a source block? And then in this, we have to do Control-C return to make it work. It's going to have something like colon column call names equals true or something is what I'm expecting. That's interesting. Wouldn't have thought that. Let me run this and see. That gets the column names. That didn't work, but I guess it's something like this. No. All right, it's fine. We will just build a data frame out of this. So let's say the data frame equals pandas.dataframe data. And then I think we do this. Alkanes. Then we're not going to do this. Actually, we can skip this since it's done down here. And let's see if this works. All right, that gives us the methanol, all of these. We see the variance is small for these, and we have successfully used some information that is extracted out of there. Seems pretty handy. Let's see what else could we do that might be valuable in here. Maybe we could extract the references. Let's try that. Extract each reference from the paper, include authors, journal, pages, year, and a DOI. Let's just put this in some kind of like JSON source. Return the results in JSON with this form. Probably should put these as double quotes. I think that's kind of required for that. right, so this should be a list or an array with these kinds of things. And let's see, I'm expecting there to be about 30. So let's just send this off and see what happens. All right, so it's going to analyze the references, currently focused on extracting them. It's kind of verbose. This is something we'll definitely want to think about. It's using I guess, one reference. Maybe I should have asked for a URL because some of these don't have DOIs, they just have a URL to the journal. So we'll probably need to make sure that those get converted correctly. I don't know if it's looking this up off-site somehow. Okay, maybe it's giving up on doing that. All right, it's really giving me a lot of info here. This is a lot of stuff I would probably want to delete at some point. All right, now it's generating. Okay, so it doesn't find DOIs for some things because there is not a DOI for this particular one. That one is a URL to the journal. Looks like we have some that are DOIs. But looks like most of them don't. Okay. I don't know why it's giving me some Python code for something. Maybe this is the final-ish result. Oh, really going on. All right, it is a little confusing why it is continuing to output stuff. This may be a feature of using Gemini. Some models are more chatty. Okay, so is it done? Looks like it's done. This looks like it should be an end source. This is the last article, or last reference. You can see down here we have the Pernod. And maybe we could use this for other, some other analysis if we extract out this using some code. Let's go back up and see where does it start. So this is kind of confusing. That should probably be begin source JSON, and then maybe we should have asked for DOI or URLs or DOIs. Then we would get both for that. All right, so not super perfect, but I didn't do a lot of work while I watched it go by. And let's see, what else can I find that could be interesting to do. Let's see what it says here about figure 8. So figure 8 has these three things in it. Maybe I'm going to ask it to see what it can tell me. Explain what figure 8 is. Pretty generic. And while it's thinking, I'll talk about it. So we have an energy variance analysis here. We're plotting energy as a function of frames, and what you see is it's going up. And then the variance distribution kind of follows the similar kind of trend. So the higher the energy, the higher the variance. And if you look at the error distribution, the higher the energy, the higher the errors are. So let's see what it says here. Presents an energy variance analysis. It displays the distributions of energy variance in MAE when energy values are arranged in increasing order. This plot collectively demonstrates that the model exhibits higher confidence, lower variance and error at lower energy levels for amorphous configurations. That's another way of saying what I said. So overall, this seems pretty reasonable. Let's see if, extract the data from the first figure on the left in figure 8. Return it in a Python script that can be run to reproduce the figure. I have no reason to think this is going to work especially well. This is a vision task, and in 20 years ago I would have used an image analysis tool and moved my cursor along to extract the data. Probably somebody still does that. It does tell me this generates an approximate data set that visually reproduces the trend. It simulates a gradual increase. Let's see what we have here. Import approximately data points visually. The original plot shows a rough linear increase. Boy, that's very rough. Just to remind you what we're trying to look at is this one. I guess in the beginning it's a little bit linear. So let's see, here they set up a lens space on the frames, that's all right. Then they approximate it as a linear function. They add a little bit of noise, that's not great. This is clearly not extracting the image. And that's okay, this should run, but it seems to be getting a little bit confused because let's look at the text properties. We've got face, gptel, response, it's a source block. That's weird. It's fontified correctly. Work, Babel, execute. But it's getting confused on with some kind of mode or something. This is surely an org mode problem. And it's probably because this is a generated plot. I usually haven't had trouble with this though. Let's see, find out if we can copy this. All right, so copying works, and but this is clearly only the vaguest of points. All right, so let's see if we can improve that. Do not approximate with a function, extract enough points to capture the trend. Just delete this because it was so bad. All right, so looks like here it has tried to do a better job. These probably look better. I think I still wouldn't use them. Because I can see maybe they already aren't super accurate. So it does look like it goes from minus 2.6. It does go up, but it looks like it's kind of stopping around here and it's not looking super sharp like that. So, all right, there would probably need to be some kind of tool or trick to get this to extract that data correctly. Let's see if we can do something maybe a little bit better. And let's just say, instead of this, describe the figure on the far left of figure 8. Note where the graph starts at the lower left and where it ends in the upper right. And let's see what it interprets here. This is also a vision model specific task, and other vision models might give different results. So that part looks okay. We have 0 frames, minus 2.6, that was the lower left corner, and the upper right end is at 6,000 at minus 1.4. So that might give you some, way to think about how valuable you can, what kinds of things are possible here. So pulling tables out looked pretty reasonable. Data extraction, maybe still dodgy. And let's see, what else could we look at? Let's do insert preset, and I'm going to pick media, make a fun, whimsical graphic image that represents this paper. Media is a preset, and it uses a tool for making images, and I believe it's using GPT 4.1 for that, even though down here it says that it is querying Claude. That's interesting. All right, so it does give me a prompt where we have a friendly robot oracle wearing a crystal ball hat with lots of different eyes. It does look pretty fun. Just check why my right, I'm going to try this again. At media, use that description to make an image. Oh, I know, it's because I have tools turned off. Let me turn tools back on. And that's important because Claude itself, this preset uses Claude to interpret the prompt, but Claude doesn't generate images, and it uses a tool that I wrote called MemeGen to do that. So I believe that it is using that tool. You can see down here it's calling MemeGen with this prompt, and it's going to save it in schnettuncertaintyadventure.png. Looks like we've got some pretty entertaining things. We've got the robot, we've got QM9 Village, OC20 Crystal City, and Gold Town. And then we'll see if this text gets done correctly, Schnet's uncertainty, and so forth. So that's literally calling a command line tool that just takes the prompt that we generated and that file name, and it is generating an image, and we should see some output. It takes 30 to 60 seconds for an image to be made. This doesn't happen asynchronously. That's why I have to sit here and wait. All right, so it tells me it did this. This is the arguments. There is our fun image. All right, now just for fun, let's also media, make a fun lyrical song to go with it. And this uses another tool that I wrote called MusicGen that creates a prompt and sends it to 11 Labs, which now is able to generate music. And this also can take a little bit, but you see down here we have an upbeat, whimsical children's song about AI science, playful instrumentation, something something, and now this one's done, and we can play it. It's kind of cute, I guess. Not very specific. We have a verse and lands. Oh, actually, what is this? Here's a fun lyrical song. Oh, that's interesting. That is not what it made. It made something shorter. But we could include this in a prompt and get a longer song. All right, so that brings me, I think that brings me to the end. The main idea today was things we might do to interact with the PDF. We looked at extracting some information, extracting some data from a table. We looked at interpreting figures, trying to extract data from figures. That didn't work as well. Maybe there needs to be a better prompt, or you need to use a tool call somehow to get a better data extraction. We can ask for images to be created that represent the figures or represent the paper, and have tools that are called based on prompts that are generated for it. So that is it for today. Thanks for listening, and we'll see you next time.